This video is on exponential growth. The exponential equation of y equals a times b raised to the power of x represents exponential growth and decay. The difference between growth and decay is the b value. The a value will be our initial value, which is your starting value. So a is the initial value, because the a is the one part that the x is not the exponent of. X is the exponent of b only. So a is your initial value, which is your starting value or your starting amount, which is also your y-intercept. The b for exponential growth will be considered your growth factor, which is, in this case, it could also be your decay factor, but we're going to deal with the growth factor. This could also be your decay factor, depending on what the value is. What is important is that the x is the exponent. X is an exponent, which is how we know this is exponential. So how do we determine if a table is exponential growth or exponential decay? As the x's are increasing by 1, or as the x's are increasing, we have to determine what are the y's doing. From 12 to 36 to 108 to 324, we can see that they are in fact increasing. But are they increasing by the same amount? If they're increasing by a constant rate, they would be adding the same amount each time. From 12 to 36 is not going to be the same as 36 to 108 with addition. So we need to determine what is the multiplicative factor of how to get from 12 to 36, from 36 to 108, and 108 to 324. Now we could guess and check, or we can use basic math. To do basic math, we can actually take the values of the y's and divide it by the previous one. So we can take the 36 and divide it by the 12. 36 divided by 12 is equal to 3. So if I do the next one, if I take 108 and divide that by 36, that will also give us a 3. So far they're the same. So this is the same multiplicative value. So we'll do the last one of 324 and divide that by 108 because I want to know the one right before it. And that is also a 3. What that means is that we, instead of guessing and checking, if we know what 36 divided by 12 is 3. 108 divided by 36 is 3. And 324 divided by 108 is also 3. Then we can see that 12 times 3 gives you 36. 36 times times 3 gives you 108. And 108 times 3 gives you 324. These are multiplying by the same positive value, same number that's bigger than 1. This means that it is exponential growth. We can write the recursive equation, our now-next equation, and we can also write our explicit equation, which is our formula, using y equals a times b to the x. So recursive goes from now-next. We can also use the a sub n, which we'll do later. So our next value, to find the next coordinate, I would then take what I have now, which was that 324, and I would multiply it by 3 to get my next coordinate. But I still need to know what I started at. I did not start at 0. I did not start at 1. It was at 0, 12. That's my y-intercept. So starting at 12. I still need to know my starting value. Now that I have my values here, I can write the explicit equation, which is my rule, which will be y equals, I need my starting value is our a, that was the 12, times our growth or decay factor. That is that multiplicative factor. What are we multiplying by? we are multiplying by a positive 3, meaning that since it's greater than 1, it's going to be a growth. And then we raise that to the exponent of x. This is our equation that we could plug in and find any value. This is our now next, so I can find the very next term to get in our table. So on this next one, again, we want to see, is it increasing? So from 50 to 60 to 72 to 86 and 4/10, it is increasing, but by how much? It's a little bit harder to see. This is why we don't want to guess and check. So in order to do this, we take our values and we divide it by the previous y value. We'll take the 60 and we'll divide it by the 50. This gives us 1 2/10. So we'll do the next one of 72 divided by 60 gives us also 1 2/10. So far, this is a constant multiplicative value. And then we'll do our next one of 86 4/10 divided by 72, which will also give us 1 2/10. That means in order for us to get from 50 to 60, we would multiply by 1 2/10. 60 to 72 is multiply by 1 2/10. And 72 to 86 4/10, we would multiply by 1 2/10. That tells us that this is, in fact, an exponential equation. This value is bigger than 1, so it is an exponential growth. So if I want to get my next value at my x value of 4, we will do my next is equal to what we have now, and we would multiply this by 1.2 to get our next y value. But we started at the y-intercept of 0, 50, so we started at the y value of 50, and that's what we multiply by 1.2, or 1 2/10 every time. Now that we have our next now, we can write our equation. Y equals, we need the a value, which is our starting value, so that was that 50, times our multiplicative or growth factor is 1 2/10, and then we raise that 1 2/10 to the exponent of x. This is our exponential growth equation. We have our now next to show how to get the next value in the table. On this next example, from 3 to 30, 30 to 300, 300 to 3,000, we can see it is increasing, but not by addition. We can probably see the value that it's increasing by, but let's go ahead and make sure. So we take our second y value divided by the first. So 30 divided by 3 is equal to 10. 300 divided by 30 is equal to 10. And 3,000 divided by 300 is equal to 10. So these are multiplying by the same amount. So we would multiply 3 times 10, 30 times 10, and 300 times 10 to get to the next values in the table. So our recursive, which is our now next equation, our next number will be what we have now times 10. But starting, the first number we multiplied by 10 was we started at 3. So our exponential growth equation, because this number is bigger than 1, is going to be y equals, the first number was 3 that we multiplied. We multiplied them all by 10, and we're going to raise it to the exponent of x. So what do the numbers in the rule actually mean? Of y equals 40 times 2.5 raised to the exponent of x. We have two numbers. We have 40 and we have 2.5. 40, the number 40, is our starting value. It is the one value that is not being raised to the x. This is our starting amount. This would be the coordinate of 0, 40 because it's your y-intercept. The 2.5 tells us that it is growth because it's bigger than 1. We are increasing, so it increases by a factor of 2.5, because that is our growth factor. This is different than growth rate. So growth factor of 2.5, because that is what we are multiplying by. We are multiplying by a factor of 2.5 each time. This is different than growth rate. So let's talk about growth rate. Growth factor and growth rate are two different things. We have a growth factor of 2.5. If we represent this as a rate or a percentage, this is 250%, because we can move the decimal twice to the right. We turn it into a percentage. Normal percentage would be 100. That would normally be the maximum percent, or to keep it normal would be 100%. 250% is 150% above or away 100%. So 150% above 100%. That tells us that our growth rate is actually 150%, because it is above. It is a positive. That means it's a growth. It is above 100% by 150%. That's why our growth rate is 150%. These are two different things, growth factor and growth rate. The rate, we change it to a percentage and determine how far away it is from 100. So 250 is 150 away from 100. And that's how we do growth rate.